I'd like to introduce our speaker tonight. His name is Arthur Waite, and he's going to give us an introduction to Microsoft Robotics. Take it away, Arthur.
Thanks. Good evening. I'm Arthur Waite, and I'm going to talk about Microsoft Robotics, and specifically their one product, which is the Microsoft Robotics Developer Studio. They call it RDS for short. It's not ROS, it's RDS. It's very similar in a lot of ways to ROS and some of the other frameworks that are out there right now for building robotics software on top of a framework platform. Specifically in this case running on top of Windows, not surprisingly. A little bit just about me. I don't work for Microsoft. People seem to think if you're talking about it, you must. I don't. But I do spend my days working on Microsoft technology. So I'm a web developer for a consulting firm here actually in Palo Alto. And so I develop websites for clients on top of the Microsoft technology stack. So Visual Studio, the .NET framework, C#, Windows, and so forth. And then as a hobbyist, I've been playing with robotics for about 10 years. My son, who's now 15 and has long since lost interest in it. Early on, we explored the Mindstorms and NXT and so forth. And I've stuck with it. He's moved on to bigger and better things as a high schooler. And then in terms of my participation with the Robotics Club here, I've been participating on and off for the last couple of years. I come to the meetings and show up on the boards and so forth. So anyway, that's a little bit about my background. The way I got into RDS specifically, obviously having an interest in robotics and a background using Microsoft technologies, last year Microsoft introduced a contest in the fall and said, hey, we'd like people who are interested to try to build a robot on top of our technology and submit some proposals, and the 10 finalists will be handed a parallax Eddy robot this year, and you'll be given 4 months to create your prototype. So I submitted, and I was fortunate enough to be one of the 10 finalists. So what I built was a robot I called the Smart Tripod. Not exactly a revolutionary idea, but it's a robot that follows you around with a video camera on the top, a pan tilt system, and as you're roaming around, it follows you. So if you're creating, for instance, how-to videos to upload to YouTube, or demonstrations, those kind of things, it does it. And I'm going to talk a little bit more about how I did that as the talk progresses. Just one other thing I've been interested in is this is a robot I created a few years ago. It's a remote controlled train. The eyes move, the head moves, the smokestack moves, so it's fully articulated. It's kind of an animatronic, really, remote controlled puppet built on just wheelchair motors and chassis underneath. And I've taken to the Maker Faire the last few years, and it's turned out to be very popular with the 4-year-old set. They seem to really respond to it and mistake it for Thomas the Tank Engine. So I changed the paint scheme recently. It doesn't seem to help. Anyway, so moving on to Microsoft and robotics. People seem to be often surprised that Microsoft has any kind of robotics presence at all. In fact, when they learn about it, they're surprised and then also sort of horrified. I think, do we really want this guy building robots? The people who brought us Internet Explorer. So either there's that reaction, or there's sort of the more pragmatic fear that the blue screen of death is not going to work in a mission critical situation. Well, the reality, of course, is a lot more benign than that. The robotics group is actually a small group. There's only about 25 people, as I understand it. They say somewhere between 25 and 50. They're a little shifty on that number. And they're an arm off of Microsoft Research. So unlike the product groups such as Windows or Visual Studio or Office, they're not really obligated to ship software. They're much more involved, so they sort of have their feet straddling both the research side of things and then this RDS platform, which is periodically updated, but certainly not at the, with the transparency or the rapidity that we see in the other Microsoft products. Just a little bit of history about the group. It was started in the early 2000s by Tandy Trower, who was a longtime Microsoft employee, spent something like 3 decades at Microsoft, worked directly with Bill Gates. In the early 2000s, he saw this opportunity. I think everybody continues to see, right? For the last 10 years, we've been on the verge where robotics is suddenly going to hit. It's going to become huge. It's the next big thing. We're where the PC industry was 25 years ago. So naturally, Microsoft was interested and wanted to get involved, and he convinced Bill Gates to fund this project. And so they started the group in 2005. And what Tandy found in doing some interviews, so he went out to the research groups, he went out to CMU and all the big universities doing research, and then also to hobbyists and then into industry, and found what we seem to have a lot of today, which still is a lot of different robotic platforms, right? A lot of things like the Parallax robot or the NXTs or the iRobot Creates or whatever it is. They're all running on their own hardware and software. To interact with them as programmers, as hobbyists, we have to get to know their way of doing things. We have to get involved in their version of whatever language it is, spin, for propellers and so forth. So we saw he saw a lot of disparate platforms, each with a unique programming model, and thought, well, there's got to be a way to tie some of this stuff together, right? We, as hobbyists, don't want to spend as much time dealing with the individual robots as we do programming our logic, right? And creating our programs. Also, of course, we are now in the heyday of the multi-core platforms and so forth, and the ability robots, with the amount of data that's coming in from sensors and the amount of output that we want to put out, obviously want to take advantage of these multiprocessors that we have in computing devices, and so he saw that as an opportunity for Microsoft, obviously as the owners of the Windows operating system. And then the other thing is, for Microsoft, they have this huge base of people just like me who spend their days working on their technology stack and have invested a lot in learning Visual Studio and .NET and C#, and who have enough curiosity and interest in going into robotics and exploring it, but probably not enough time to move over to some of these other platforms. For me, I'm very interested, very curious about ROS, but with a teenage son and daughter and so forth, to learn a whole nother technology stack is hard for me. And so I like the idea that I can take what I already know and apply that to something. And so they saw that as a big opportunity with several million .NET developers worldwide. Why not? In fact, Tandy Trower said that he talked to Red Whitaker, who heads up the CMU robotics platform program a while ago, who they had no interest in going to Microsoft for their technology and weren't about to do it, but he encouraged them to get involved because I thought, sort of all boats rise, right? So the broader we get the interest in robotics out there, the more people who are trying to develop applications, the better it is for all platforms. At about the same time, Bill Gates, some people may remember this, has got a big splash back in 2007. He wrote his big article about a robot in every home. And that came out pretty much simultaneously with the first iteration of Microsoft Robotics Development Studio. So they released their first iteration of it in December of 2006, and sent it out to the world. The main features of RDS, and it hasn't evolved a lot. A lot of these, there has been some evolution over the last 5 or 6 years with it, but it's largely the same product that came out a few years ago. So support for lots of hardware. I'll show you this. This is an important piece of it, right? The idea that I can use iRobot Create, I can use a Lego NXT, I can use a Parallax robot. All of that support comes out of the box with RDS. The concurrency thing, so the idea of taking advantage of multiple cores on the PC, the ability to take data coming in and also processing information at the same time, sending messages out, all of that happening at the same time, taking advantage of that is built into RDS. We'll talk a little bit about what that means. The other thing they built into the product was something called a visual programming language. So those of you who have worked with Lego NXT, you know the boxes. You drag this stuff around, build the blocks, program logic. Very similar here. The idea being that not everybody wants to, especially in an educational environment, not everybody wants to have to learn to code. So if I can do this visually, prototype things quickly and so forth, that was a big part of what they put in there. The idea that we could get this into hopefully the hands of younger people and people who wanted to not bother with the heavy-duty programming. A visual simulation environment. I'll show you this as well. This is really interesting. They've got a physics engine and a 3D environment into which you can run your application. So if you don't have a robot, you don't have a Create, you don't have a Lego NXT, you don't have a Parallax robot or whatever it is, but you've written software and you want to see it run, you can do it in their simulation environment, which just runs on your laptop. Obviously it's not the real world, but you can put obstacles in front of it and work with depth sensors and that kind of stuff. So that's there too. And then finally, obviously, a key advantage again being that people who are developing on the Microsoft technology stack are going to be familiar with it. So these are some of the robots that are supported out of the box. The Parallax Eddy. This one is, I'll talk about a little bit more. Parallax, everybody knows who Parallax is. They're off the Sacramento area, right? The makers of the propeller, the Bobot, huge presence in the robotics world. They worked with Microsoft last year to create the Eddy, which is an implementation of a design, what Microsoft calls their reference design. So the idea that we want to create and they published a reference design, a robot that other manufacturers could build, anybody could build, but they hired and worked with Parallax to create this particular one, which has is sort of the beefier sort of version, maybe the Create, and sort of their answer to maybe what the TurtleBot is, right? So some sonar sensors, infrared sensors. It's got a propeller chip as the brain, of course, USB input for serial connection between your laptop. You have to run a laptop on it. That is the actual where the logic lives. And then the Connect sensor. So this is the thing that is a little more, what Microsoft has come out with a little bit more recently is native support in RDS for the Connect. And of course, the Connect has been a huge hit for Microsoft and a huge success. Roboticists, within weeks of having it released, were already hacking it. Microsoft eventually recognized that there was a market here and released an SDK for it, and then the robotics group wrapped their code around the SDK, and now we have support for the Connect in RDS. So iRobot Create, other robots that are supported, obviously NXT, Bobot, this Lynx Motion arm, and there's a few others out there. What this means is for the manufacturers is that they're writing what Microsoft calls services that allow us as developers to talk to these robots through contracts and interfaces, and I'll talk a little bit more about what that means, so that we can spend our time worrying about high-level logic, the logic that we want our robot to execute, as opposed to having to worry about the communications protocols and all of that. So what's required to run RDS, Visual Studio, is the development environment. For people who are familiar with the open source world, sort of the Microsoft equivalent to, say, Eclipse. A very rich programming environment. I like it a lot. Very, very powerful. The new version that just shipped, 2012, Visual Studio 2012, is a lot faster. Usually that's the biggest complaint people have about it, is it's this slow behemoth, as ultimately a very glorified text editor, but very powerful. The .NET framework, of course, is the runtime engine, again similar to, say, the JRE for Java folks, that runs the interpreted code, RDS itself, and then Windows. So you can see all of this stuff is free. You can go and download it today, except Windows, and that's where Microsoft, obviously, they're not in it for their health. They're in it for the shareholders, and so they you do have to run on Windows. And their big hope is it's sort of the whole, we'll give you the dog and sell you the dog food. We give developers all these tools for free. We want you to download this stuff. We want you to use it. We want you to build applications. And we hope you'll build the next, the next big thing, and we'll sell a ton of Windows licenses on top of that. So going into RDS and the architecture itself. The meat of the robotics development studio, the technology, are these two orange bars that I've got over here. One is called DSS, Distributed Software Services. I'm going to spend a little bit of time talking about that. CTR, the concurrency and coordination runtime. I'll talk a little bit more about that, but everything is running on top of these two pieces of technology. Really, CCR is what's handling all of the concurrency, threading and the multi-core stuff. And then DSS is what's handling the synchronization of communications between the different aspects of your software and the robots and the hardware and so forth. Both very, very interesting and powerful pieces of technology. So for those of us then who are writing software on top of RDS, we're on the right-hand side. User interface, obviously we have Windows, we have a visual environment. Typically we want our robots to have some kind of visual interface so we understand what's going on. RDS supports HTML, so you can be doing web output. WPF is Windows Presentation Foundation. That's their big presentation technology these days. There's a few others that you can use. So you've got that on top. Your stuff is sort of there in the middle. This is right where you're writing all of your logic. You're deciding what to do with the inputs that come from sensors and how you're going to turn that information that's coming in into outputs for your motors or actuators or whatever they are. And then when what you're then talking to are the lower level services. Again, what we call services in RDS. And that is whether it's the brick for the NXT, or the propeller, the board, and the parallax eddy robot, or whatever it is. They're these services that have already been written, and your job is to talk to those through these interfaces. So anybody who does enterprise business programming, business software, you're familiar with the idea of separation of concerns, single responsibility principles, black box programming, right, where we want to be able to write code that is isolated in what it does and is responsible for one little piece of functionality, and then put it away, and we can talk to it without worrying about exactly how it's working anymore. So these services, for instance, when I write, or when Parallax or somebody writes a service for the Eddy robot, I don't care how it works. All I want to know is that I want to say drive forward a distance at a certain power for a certain amount of time, whatever variable I want to use. Their job is to expose that capability to me. I don't care about what it takes to actually talk to this board. I don't care what bits are going over the wire. I don't care what, I don't need to know any spin in the case of the parallax stuff. I want a very simple interface that I can talk to and abstract away a lot of that complexity. So that's really what this is. And the power of these contracts, again, the idea of a drive contract. The idea is here that I can write my code and say, drive forward. That contract was written, in many cases, it can be written by Microsoft. They expose a number of generic contracts, such as drive, depth sensor, touch sensor, and so forth, that I can work with, not worrying about what's underneath. And it means my core code is portable, because all these guys have implemented their version of what drive means, or what a depth sensor data coming back looks like, or what a touch sensor, touch is binary, it's either on or off, and I don't care, as long as I get that bit that's either true or false, that's all I care about, don't care about what happened underneath. And so that's what these contracts are. It makes coding a lot easier because all that complexity is taken away. So CCR, I'm going to talk about those two orange boxes that are on the left, concurrency and coordination runtime. This is the one that's responsible for sending messages back and forth between various pieces of your code in a concurrent manner. So For anyone, how many people, by the way, are familiar with Microsoft's technology and code in Visual Studio and .NET? Okay. How many people on the Java side doing enterprise application development? A few folks. Okay. One of the toughest things for those of us who are doing this type of applications is taking advantage, again, of these multi-core processors and writing code in what's called a multi-threaded way, right? Simultaneous processing going on. This is very, very tricky to do. We want that power. We want to take advantage of all these cores now that we've got on our computers, but it's very hard to synchronize information that's going back and forth, right? You can imagine processing an image. If I say that I want to interpret some data in this image and I'm going to send out the request to 4 different processors, who's going to be in charge of keeping track of all that data coming back and making sure that it's all synchronized? Who's in charge of sending it out in a meaningful way, making sure that work isn't being duplicated, that it's being done efficiently, and so forth? That's complicated, very tricky stuff. And I've done a little of it, and I'm glad that I'm not having to do it anymore. So the CCR, the advantage there is that I can say, I've got this image frame that came in from the RGB camera. I want to process that frame. So I'm going to tell CCR, go off and process this frame, go interpret it. Meanwhile, I want to make sure that I'm not running into anything. And I want to make sure that my depth sensor, whether it's the sonar or the infrared, I want to make sure that it's able to send a signal through and that I'm catching it. So all of that, sending this stuff out and not trampling on each piece of code, is what's handled by the CCR. The way the CCR does this is through what they call ports. This is getting more into the semantics of the RDS, which I'll try to avoid. But it's essentially these queues. So the idea of being able to take a task, stick it into a queue, send it off, and then it's up to CCR to figure out how to get the various threads that are available to process it, whatever the cores that are available to process it, and so forth. So as programmers, we create these messages or these tasks. We throw them over the fence to CCR. Its job is to go off and take care of it and report back success or failure or whatever we want when it's done. Now I'm going to show you a little demo code in a minute that'll hopefully illustrate a little bit of this better. So DSS is different. Its job is you're using CCR for writing all your little processing code and so forth. DSS is the larger infrastructure that's responsible for coordinating all these different services that you've written. So in the case of the robot, I create the tripod robot. I have a service that's handling the pan tilt mechanism. I have a service that's making sure that this thing is driving in the right, in the right way and so forth. And DSS's role is to make sure that the messages and so forth are getting passed back and forth to these different services. What's really interesting about this is that this technology allows the idea of creating a truly distributed robotic platform. So you can imagine a case where you've created a service that maybe is running on one robot, one laptop, one robot, and one that's running on another one. The DSS, because it's using what they call a RESTful model, it's just XML being passed back and forth. They can be passed between processes on your computer, or it can be passed between computers over the network. So the ability now to create, instead of just one program that's running an NXT, you can create a program that's running multiple NXTs or multiple networked robots can all be talking to each other. And that's out of the box with DSS, which is really interesting, is to have that ability to say, I don't really care where a process is running anymore. I don't care where a service is running anymore. It could be anywhere, which makes it, sort of the notion of these networked robots and cloud-based robotics, which has sort of become a hot term, is all possible with this technology. Publish and subscribe model, the idea then that I can send off a message to, whether it's the robot or some other robot or another service, and wait for a response, or it can subscribe to me. So I may have a service that I've created for, let's say, an Xbox controller to drive my robot, and it's obviously creating inputs. and somebody wants to subscribe to that. So I have maybe the robot wants to subscribe to that. Maybe I have 2 or 3 robots that are going to subscribe to it because I'm using the Xbox controller to control several things. In fact, for the robot that I created, the tripod, the pan tilt functionality at the top is a separate entity, separate service, completely isolated from the robot at the bottom. And yet I was able to use the Xbox controller to control both the movement of the robot and the pan tilt functionality separately when I wanted to control it manually, because I just had them subscribe to the Xbox service, right? The Xbox service doesn't care who's subscribing to it, it just sends out the messages. All right, he hit the red button, firing off a message, and whoever cares is going to get that message and respond to it appropriately. Okay, so let's, I'm going to pull up Visual Studio, and I'll just show you real quick a little bit about what, if I can go in the right direction here. What the code here might look like for a very, very simple service. Now, this is a lot of I know there's a lot of noise, and it's going to be hard for me to drive because I can't really see here very well. So this is a very simple. This is a tutorial that comes right out of RDS. A very simple tutorial. Tutorial number 2, in fact. And what it's showing is using for the NXT here, the Mindstorm's robot, creating a bumper server, or subscribing to a bumper service that, when pushed, will start or stop a motor. So basically your hello world for robotics. What we've got here is sort of the initial setup for the code. So we need to subscribe to the services. So that, again, this notion that what was provided out of the box with RDS was the notion of a bumper service. I don't really know what this bumper service does. All I know is I'm going to subscribe to it, and somewhere underneath, somewhere in the bowels of RDS and the NXT service that Lego wrote for RDS, the bumper service is going to send me a signal when this thing is touched. I don't care how it works. And the same thing is true then of the motor service here. I'm subscribing. It's one long line of text. But I'm subscribing to this motor service here and saying, I'm going to send you signals to either start or stop. Again, I don't care how you do it, but I'm going to set that up here. And then we've got a bunch of other junk for setting up. And then the actual, if I can get back to the scroll bar, the actual code for executing this functionality. So we've got a start method. Everything starts with the start method. And then we've got these little handlers here that do the work. So I've subscribed to the bumper service, and I've said, when I get a bumper signal, when I get a bump signal, do this. And that's what this is. I'm getting an update notification is sent through, and then I can write my code here. Not really caring how that message is sent to me. I know it's going to come through DSS, a port of some kind. Oops, let's go down a little bit more. And what I'm going to do is in this case, either turn the motor on, right? The state of the motor is, I'm basically in this code here reversing it, right? If it's on, turn it off. If it's off, turn it on. And then a little bit of logging information and setting the power level and the logging information and so forth happens there. All right, so pretty simple stuff in that all of the one thing you'll notice here, nowhere do you see the word Lego, right? Nowhere do you see the word Mindstorm. Nowhere do you see any reference in this code, other than maybe in the comments, to the fact that this is going to tie into this Lego robot. And that's again because all of that is abstracted away. And using a configuration file, I can say, use this code for this device. I could also say through a configuration file, I want to wire this up for the parallax robot or whatever instead. So again, that level of abstraction is kind of nice. So what I'm going to actually, what I'll try to do here is run this. Make sure we're connected. Let me do this one. Then start the debugger. Now over here on the other side, let me pull this over, is what's happening is DSS has started. That's the communication service. I just heard a big beep here. And so what's happening now is I push the button, the motor's running, turn it off, it stops. What's interesting, you notice no wires or anything. This is all happening through Bluetooth. I did not download my code into the NXT. This is running, and this logic right now is running on the laptop computer, and it's sending the signal, the start signal for the motor, the stop signal for the motor through Bluetooth to the robot, and that's, you know, again, it's Microsoft. You have to run this on Windows. They're not going to let you download it onto the device. So for something this simple, obviously, you just write the code in native whatever NXT and download it onto the firmware, onto the hardware here. But you could imagine creating a service that was talking to 3 or 4 of these things, right, and coordinating their movements. Because I can get the sensor inputs onto the laptop and into my code here. There's no reason. There's nothing that prevents me from supporting multiple robots, and that's where it gets interesting, right? Taking advantage of the laptop.
Do you need to update the firmware? Anything? Nothing to do with the MyStop?
No, this is native. No, there's nothing on here that is. This is native. I just put I had to install the drivers onto my laptop that come from Lego. And but that's it. It's just it natively supports a Bluetooth communications. So yeah, Microsoft's just writing that on top.
Transmits some code to the NXT robot, would it not?
Well, it's transmitting whatever I don't know, whatever the binary or the serial communications that are happening between. So the service that Lego wrote for RDS, it is running on my laptop right now. It is sending whatever native language that the NXT understands, sending it across. And so we know that, out of the box, it does support serial communications, right?
Send some code for you to know when you press the button to know that.
Well, I don't know that I don't know that it's code. It's information, right?
Yeah.
In fact, what I could do here is set a breakpoint and prove that I won't all this time. But this is running on the laptop, and again, it's just sending information from the laptop to. I don't think it. I don't know what the data is. It's actually going through there. All right, so that's our little demo. I did want to go over. Just a couple of the other features here that we've got. The visual programming languages is just a slide. I'm not going to go further into this. It's just a still, but it shows the idea of dragging those blocks around, right? So if you don't want to write the code using that functionality, let me back out of this for a second. Yeah, that's all right. And then the visual simulation environment as well. So what's interesting here is that, and I'll show how I can set this up after the meeting here. I'll have to plug in the laptop, get this running around. But this exact same software that was written for running this Eddy, in this case it's the demo software is what I'll put up here, can be run in the visual simulation environment. And the visual simulation environment has a few different settings, so inside a house with obstacles, it can be outside and so forth. And the user interface and everything is identical. It literally is the same code that you'd be running on the device itself. They've obviously programmed the availability for it in the simulation environment. They had to create the model, they had to create the physics and functionality for it, but that's all built in there. So I wanted to talk just real quick. I'll show you the demo of the project that I created. I mentioned that this was going to be this autonomous camera person. We found out in January that we had been, the 10 finalists had been allowed to create this thing, and for me that was the spur to finally start learning RDS for real. I'd done basically these Hello World things in the past, but I hadn't dug into it. So this thing arrived by UPS in January, and we had till the end of April to finish this thing off. And the final presentation was supposed to be in the form of a video. So what they said was, upload a video of your robot doing its thing, explain how it works, upload that to YouTube or Vimeo or whatever. Has to be there by April 30th. Send us a link and we'll let you know. So having created a robot that was all about making videos, I decided obviously this would be the thing to use to create my video. So what I actually did was to prove, I figured to prove that it would work, and that it would work in a scenario that I had presented. I said this would be a thing for people who are creating home videos, demonstrations. YouTube is full of the how-to videos and so forth. So I decided I liked to cook. So I said, I'm going to make a cooking video, and I'm going to use this thing. And so that's what I did. I created a cooking video. I'm spending in my house showing how to make baked rigatoni. And then I created a second video, which was really what I uploaded to YouTube, which showed how I made, it was the making of the video, where I showed how I actually did it. So here, I'll run a little of that here if I can get it to play here. So this is the actual finished robot. This is the Eddy with a laptop running on top of it. I mounted it's a commercial tripod, very lightweight carbon fiber tripod. And then at the top I made this custom head out of wood, and there's the Connect sensor on the lower deck. And then on the upper deck, this is what's called a Fidgets. This is a company that makes these little USB devices. And the USB cable goes right back down into the laptop. And it's what's in controlling the pan and tilt system up above. So we have up here these two servos, both for panning and tilting. And this pan tilt mechanism is made by a company called Servo City, who does a lot of this stuff. And then I had a little wireless mic on the left there. And then that's because I was using my camera for filming this, I stuck a really old video camera there at the top. So this is the user interface that I created. Again, I used the Connect and the skeletal tracking feature that's built in out of the box with Connect to track the position of my body. And you can see this is sort of the telemetry that's there, some other information. The video that's showing here is the RGB video that's coming out of the Connect sensor. It's not the video coming from the camera, from the video camera. I'll show you that in a second. And then I created sort of these different functions that the robot has. So a follow mode, which is when I'm moving back and forth. A dolly mode, which goes side to side, and then a static mode. So this is my video. This is the smart tripod doing its thing. You can see I'm talking to the camera, and this is the actual video camera, and it moves pretty nicely. I mean, and here's the behind the scenes video. I actually thought it's better than what my spouse probably would have done. So here's the turn. So it does a pretty good job. You can see I'm not jogging. I'm walking deliberately, but not particularly quickly. Here's sort of the dolly mode where it's going back and forth. There's a little wobble in there. Here's what the camera actually captured. You know, a little jiggly, but pretty good. And here's one I prepared earlier. This was the one thing the kids were willing to put up with was, hey, we're going to clean up the kitchen, we better get something good out of it. So then the other thing, I built in some other functionality that was a little more interesting. In this case, I had the Kinect track my right hand while I was track my left hand while I'm gesturing with my right hand. So I'm able to control the camera movement, you can see with my left hand, while I'm doing close-ups with the right hand, which is using gestures for controlling the system opens up all sorts of possibilities. Here's another one where I created the idea of what I call these Q zones, whereas if I moved my hand into a particular area in space, I wanted the camera to follow my head, and then if I lowered my hand, have the camera look at the pot of food. So it gave sort of this conversational, effect, and looked somewhat natural, right? It looks like it looks like there's hopefully a person back there. So anyway, that's enough of that. So anyway, so the end result was it was good. I actually ended up winning the grand prize in this, believe it or not, in the contest, which was a lot of fun. So Microsoft came to the Maker Faire in May and had me come with the tripod in their booth, and I got to hang out with all the really smart, all the PhDs, robotics PhDs, and they sent out a press release. So I got written up in Servo and Robot Magazine and Engadget, which was that's where the traffic is. But the best part was this month's Popular Mechanics magazine. There's this blurb on the right, and what I love about this is the illustration. That's me in a chef's outfit, apparently, holding an omelet, I guess. And what I like to say is the guy on the page over here is a Lawrence Livermore Lab rocket scientist. So I'm the guy, I'm not a rocket scientist, but I'm the guy on the page holding the plate of food standing next to the rocket scientist. Anyway, so conclusions about RDS, what I've learned, what I came away with. No doubt in my mind, I had a great time with the platform. I learned a tremendous amount. It is very powerful. GSS in particular, the distributed capability, the notion of being able to control multiple devices, multiple services, and have all this sort of magic happening underneath was great. The concurrency stuff, the reality is it's getting dated, and I think Microsoft knows this. In the .NET world, there are now better ways to handle multi-threading and so forth. Microsoft has kind of surpassed itself with the CCR. The CCR is a little dated. Problem is right now, if you want to use RDS, you're going to use their concurrency functionality. And so even on their forums, the Microsoft guys themselves will say, think carefully about what you're really trying to accomplish. With a lot of robotics stuff now, you may want to use native .NET and not necessarily go the RDS route. There's some trade-offs there. What they do say is if you're interested in the idea of this distributed stuff, DSS is still very powerful. If you work with any kind of things like WCF, Windows Communication Foundation, which is the service-oriented architecture, again, communication over web services and all that. That's very similar to what DSS is, and there really isn't a better solution for that right now. Testing is hard in RDS. Yeah, they have the visual stuff, but there aren't the easy ways of doing things like unit testing, which is what we call it. And people are dealing with ROS, working with ROS. I know they have, my understanding at least, is a big unit testing framework built in. There isn't really anything like that, which means to test your code, you just have to run it. You have to run the robot and put up with the dents in the wall, because there isn't really an easier way, aside from creating your own sophisticated testing system, to handle that. the learning curve is steep. I mean, it's steep with all of these platforms, right? ROS, I understand is tricky to learn too, and sort of the other large platform-based systems. They take a long time. To learn. Again, this platform came out in 2006. They have made these incremental updates to it. They say, the next thing is coming. But because they're part of the research group, they're not transparent. To Microsoft's credit, they've become much more transparent about their futures, about the stuff that they're working on, about releasing previews, about talking about roadmaps and that kind of thing. The robotics group just is very, very quiet, and I think that's sort of because of their research roots as opposed to their product roots. So we don't hear that much. If you're interested in getting started with RDS, this is the Bible. It's really thick and heavy, which speaks to the complexity of the platform. Trevor Taylor is the guy on the right. He actually, after he wrote this book, got hired by Microsoft and worked in the robotics group for a while. I think he's moved on to the Windows Phone group or something like that since then. So that would be the thing to check out. Resources, Microsoft.com/robotics is where you can download all the stuff. Parallax.com for the Eddy, if you're interested in that platform. And then some links here. I've got some more. The Eddy robot stuff has a little bit more of the video. You can see the full submission that I did if you're interested of my smart tripod robot. So that's what I've got. Thanks for the attention and the time.
Thank you very much. Do people have any questions? Let me give you a microphone. Okay. You said that the testing was very tough, but what about the debugging? Once you find a problem?
Yeah, well, the debugging is part of the testing. The debugging, it depends on where the bug is. Part of the problem with multi-threaded and this concurrent stuff is sometimes you're sending things off a task, and telling this thing to handle it. When you're trying to synchronize results, sometimes it's hard to tell who came in first, what information came in first, why this time did I get one result, why the next time did I get a slightly different result. And that's again because of this parallelism that's going on, right? Having all of this stuff happening at the same time. And it's very, very hard to create something that is 100% reproducible over and over and over again, especially if you're relying on sensor data, and that kind of stuff that just is variant by its nature. The Connect folks actually, and I don't think this is supported yet in RDS, the Connect folks have released basically a TiVo for Connect, for developers. So the idea that you can record something, inputs into your Connect, record it, and then use that recording over and over and over again as input into your code. So as a proxy for your Connect. And what that means is then you really can test the exact same scenario over and over and over again.
So how about with this simulator? Is it possible to make it deterministic and also non-deterministic?
You know, I have to admit I haven't spent a lot of time with the simulator, so I'm not. I think it has that sort of that reporting capability, if that's what you're sort of referring to, but I'm not. Yeah, I'm not sure how far that goes.
Okay. Any other questions?
Sorry? I didn't hear that.
Test. I'm curious about the Connect. How much of the work was Connect related, and how much for the rest of it?
For the project that I did?
Project, yes.
Yeah, I have to admit, the Connect does a tremendous amount of the heavy lifting. So it provides natively the skeletal tracking capability. So you stand in front of it and it'll recognize a human being and provide you with distance information for each of the and X, Y, Z and axis information for each of these parts that it's tracking. And then it's really up to you to decide, well, what do you do with that information? The trickiest part is as I learned at the Maker Faire when I had this thing running, is that the Connect is non-discriminating about people. It loves everyone. And so as soon as someone enters the frame, it'll start tracking that. And the next thing you know, your robot is wandering off because someone has walked in front of you. So I had to quickly make this adjustments to the code that ensured that once it grabbed onto one person, that it either kept that person or just stopped. Sorry?
How difficult is that kind of program?
I don't think it's it's not that tough. This is, again, I have experience on the .NET platform. I've been doing a lot of work on it for years, and so I'm comfortable with Microsoft's syntax and their object-oriented nature of their libraries. And they, of course, wrote both RDS and their Connect SDK and everything with the .NET developer in mind. So I think there's probably maybe some initial learning curve there if you've never touched their stuff before. But C#, by the way, is it's very Java-like. It's very C-like. It's all these languages seem to all ultimately they all kind of it's just syntax, right? They all do basically the same thing. It's just semantically different. Anyway, so I found it pretty straightforward to work with. Yes, sir.
Well, yeah, I'm wondering whether the same interface did you use the code and
Did you use the native Connect API, or were you using the Connect services exposed through the RDS?
I use the Connect services exposed through RDS, which simplifies things. They've since, again, Connect has come out with advancements to their SDK. Right now, the latest version actually has facial tracking. So it's not just skeletal tracking. The new version of the Connect SDK will identify a face, put a mesh over the face, can actually track the positioning of your head. Which, for this application, I think would be really interesting, right? If you turn your head, maybe the camera sort of follows a little bit over or whatever it is, which would be a lot of fun. The RDS service is not supporting that. I'm not sure that they are going to support that. So that would be a clear case for me to say, all right, maybe it's time to start looking at moving into native .NET for my project rather than RDS for that.
Which came first, Eddie or the Turtlebot?
I'm sure it's a Turtlebot. The Eddie came out, I want to say, last fall. Yeah, so I'm sure. I think the Turtlebot was long before that.
Did you try any voice recognition connection? Because
No.
what I found out is really hard to buy or build any sensor. Sometimes you just use a voice, like, hey, you meet somebody, and then you serve like a sensor input. Say, if you meet a girl or somebody and say something different, right? That would be like telling them, you saw something other than program. It was all the sensor, buy all the sensor.
Yeah.
You try that.
Yeah, I didn't work with the speech recognition built into the Connect. That is available, and I understand that it's gotten better with the recent SDK update to the Connect. One of the other contestants in the contest I was in did work with it significantly, and I think had some success with it. He, by the way, one of the other guys who worked was an entrance in this contest. He used that VPL, that visual programming language, so the drag and drop thing for programming his robot. Very, very sophisticated. He got a long way with that. He did have to write a little bit of code, but it's a very deep graph, huge amount of branching logic and so forth that he created. But it was impressive. It showed how far you can go with that, with a visual programming language.
So the computer sends Bluetooth to the NXT bit of data. How does it talk to the propeller? How does it work?
That's USB. So
Wouldn't that make it a serial stream? Are you taking advantage of the cogs and the propeller that way?
Yep. So the board here, by the way, it's not just a propeller. It's a full board that Parallax provides, and the board has a propeller as its obviously it's processing core, but it's got I/O on there for the sensors, it's got for the motor drivers and all
Does
that.
RDS talk back and forth to the propeller, or does it just compile and download?
It's no compiling and download.
Okay.
That wouldn't sell Windows.
Have you had commercial interest in your robotic cameraman?
people seemed curious about. What's interesting. Well, there was two reactions, groups of reaction. One was it got posted and circulated on a lot of cinematographer and videographer blogs and forums and so forth. And the reaction there was, hey, I can see using this as a second cameraman on shoots, right? So I want to run the primary camera, but I'll set this thing up and maybe even just in static mode and have it be the B camera. And then the other reaction was, this guy's trying to steal our jobs.
It looked great.
Thanks. But yeah, no serious commercial interest, I don't think. This, as a prototype.
Okay. Let's do two last questions.
So you mentioned the software is free. Are there any restrictions on using it in commercial products?
No, there's not. Interestingly, for a while, the RDS was under, you had to pay for it, and there were some licensing restrictions and there is a license, everything has a license associated with it. But you're absolutely, you use it, resell what you build, they don't have any problems with that, they want you to do that. They used to actually license it separately, and I think that was when it was a little newer and exciting. They did have, and they were supporting it quite a bit more. And this will date it a little bit. They were selling CCR and DSS as separate products outside of the realm of robotics, right? Because for a while, that CCR was the best answer to doing really high volume concurrent programming. And they like to talk about MySpace. Remember MySpace ran all of their stuff on CCR, and they were loved it. I remember going to a talk with the MySpace guys, and they were very, very bullish on CCR at that point. Again, there's other, MySpace isn't really around anymore, and now there's other options for CCR. Yeah.
Okay. One last question.
Yeah, just to continue on the way Microsoft communicates with the robot. I understand that it does a Bluetooth for NXT, and the NXT already has native code to talk to all of its sensors, all of its motors, and everything like that. It's, I guess, kind of a two-part question. Can you put the Microsoft robot program directly onto the robot so it doesn't have to communicate from a laptop? And also, how was it done with the Paralabs?
Yeah. So it. And I know that's sort of a confusing area here, is that the brick, whether it's the processor on the Eddy here, the board on the Eddy, whether it's the brick on the NXT or any of these others, they're responsible solely for reacting to input that is coming from the program running on your laptop. So they are acting, you might say, as interpreters, proxies, middlemen, whose job it is to take this communications that are coming from the high-level thinking that's happening on your robot or on your laptop, and then turn those into the signals that actually drive the motor or whatever it is. So there is no option for downloading your software from RDS onto any of these robots. You have to have your software. It runs on Windows. It runs on a .NET framework. That is an absolute requirement. It's very similar to ROS, right? It is. It's running Spin. It's running. So it has its own software on there, and what you're doing is you're sending down serial information. Again, you're saying, Spin, tell your motor to go forward X, whatever at half speed or whatever it is. So it is a proxy at that point, right? And you can look at the spin code. The spin code is all there, and it's receiving signals from RDS and is interpreting those and then executing. Yeah, and maybe it's, I don't know the details of what, that's the way I like it. I don't know the details of exactly what's going on in the lower level there.
To write your own code that runs your computer, that runs all the sensors and the motors and everything, and then Microsoft is just kind of like an extra brain that will process all the information and tell the robot what to do. It seems kind of like a limitation. I feel like with ROS you can write, even down to the driver level in C, C++, control every one of the sensors, and as long as the processor on board is powerful enough to run some flavor of Linux, you can throw it right on the computer and not have to have
Right. So the point there is that you're running Linux. If what I hear you say is correct, is you're running Linux on the board, right? That is a limitation here. Microsoft, has gotten into the Windows Phone thing, and there's talk about ARM processors and so forth, and about the .NET framework running on ARM and so forth. It'll be very interesting to see if they can make that leap, because again, absolutely, right now you need to be running on Windows. RDS runs on Windows. Doesn't download anywhere, doesn't run on anything else. So it's a communications going back and forth. That is a limitation. For me, I see it as an advantage because I don't have to worry about the lower level stuff, and that's what I think that's progress, right? When we get to the point where we don't have to worry about some of that lower level stuff, that's been taken care of first. I don't write assembly language either. I don't want to have to do that, and so we're slowly moving up the ladder a little bit. The idea being that this is a software that allows us to abstract away some of that complexity, and that's always sort of been what Microsoft has been about in terms of development for developers, is for better and for worse, and there is a lot of worse there, is abstracting away some of that complexity for developers so that ultimately you're writing what matters, which is your logic, right? And getting out from under having to do the bit twiddling and that other stuff.
Thank you very much.